Hello all, welcome to ASC Calcitech webinar series. Today we are moving ahead with Calcitech ASC success stories, second part of it. That is, today we are focusing on 61850 upgrade cards for transformer monitoring system used by some of the original equipment manufacturer in Europe and North America. So these manufacturers focused on the different types of transformer, its monitoring equipment, and want their complete system to be upgraded to 61850 in an easy manner. And one of the customer is in Europe and another is in North America, and we will provide detail of their use cases. Last session we had was on the Calcitech ASC success story based on national level configuration management and fault analysis system for a major Indian utility. We have provided a detailed insight into that, and you can see, if you have missed the session, you can see the corresponding GoToWebinar session in the same link that you used to join this webinar. Today's agenda, we will run through the business case, then the solution with the implementation details. The major highlight of the solution is Sync 200 series, so its boards and its highlights, detailed integration workflow, Sync 200 series interfacing option, most common protocol used in 200 series, its time sync options, fast message goose bus that is used to transfer the fast messages from I/O directly, and other key features, then OEM module comparison, and we will move ahead with what are the key benefit the solution had offered to the customers. So these are some of the insight into the session. Let's move ahead with the business case. So both the customers we were discussing, one in Europe and North America, were original equipment manufacturer, and they were selling multiple power transformer and its monitoring equipment involving the dissolved gas analysis and moistures in oil, etc. And they were monitoring the transformer condition in real time and taking remedial action accordingly. They both had a good market share with respect to the transformer monitoring scenario. So they were using a very primitive protocol like Modbus for transferring the data to the external system, and as you know, the Modbus had features which are very rudimentary, and different timestamp for the data are not available. There is no facility for the time synchronization, or exchanging the real-time events are not permitted. So these are some of the bottleneck in the Modbus or other primitive protocol. So they want a quick migration to the latest protocol like 61850, DNP3, 104, or monitoring their network over the SNMP. And some of the cases the customer wanted single protocol, single slave protocol, to send the data to their analysis system. Some other cases they want multiple data onto the multiple protocols and multiple system, so they want the same system to have multiple protocol, that is 16850, and for the remote sending the data to the remote 104 or DNP3, and for monitoring the network and other status they want a SNMP. So multiple combination were required in some of the cases. And another use case is they were using their own tool with the Modbus for configuring the stuff, and they want to maintain the same tool itself, same configuration scenario itself. So they want an interface through the externally exposed Ethernet port for this latest protocol to do the configuration of their devices directly using the same tool. That is one of the requirement for the configuration option. So that is one of the key use case scenario they were focusing. And they want, as I have mentioned, they want a single or multiple protocol scenario, and they want to do that just by the licensing manner, and they want multiple options like a copper Ethernet interface or fiber optic Ethernet interface, and that need to be decided on the delivery time. They, in some of the cases they want a 61850, some of the cases 104 DNP3. So they also want that to be managed by just licensing, nothing. They do not want to complicate the system just by licensing or pluggable interface cards. They want to migrate to a copper or fiber. In some of the latest cases, they want to have a dual Ethernet support, and a PRP based network redundancy was one of the requirement in the new upcoming cases. So one of our customer completely migrated to the dual Ethernet with the PRP based network redundancy. And OEM, this customer wanted a fast migration to the latest market because of the market pressure. So that is one of the key requirement, that is they want a migration to 61850 within a time frame as low as 1 month period. So these are some of the business case that is addressed by the upgrade card solution for the customer. Now let's move ahead with some of their implementation detail. So this is the indication of a transformer, and its monitoring equipment is shown by the side here, and this is sent to a analysis system. So this is the overview. So this system earlier had a primitive protocol like Modbus. So what they did is they took the unit out, and they want to upgrade it to the latest protocol like 61850, DNP3, 104, etc. So what they did is used Sync 200 OEM module. There are multiple variants. 221 is the with the smallest footprint. 241 is having an option of copper as well as fiber optic Ethernet, and 261 is having a option of dual copper or dual fiber option. So they choose the module based on their requirement, and it has got a TTL interface for interfacing with the existing microcontroller. So TTL interface is used to interface with the existing microcontroller and exchange the data over the Modbus, and then this OEM 200 series OEM module will directly convert that onto the Ethernet port. This Ethernet port is exposed outside, and this Ethernet port can have 61850 or DNP3 or 104, etc. this on this port. So this port is exposed outside, and that will have a latest protocol. So that is the overall solution for the complete transformer and dissolved gas monitoring system, and both the customer had an installation around 10 years, more than 10 years now, and they have completed around 5000 installation, and it also had a pass-through interface through the Ethernet port itself. So that is used for the configuration management. As I have mentioned earlier, existing tools can be used to configure the complete system, map from Modbus to 61850 or 104 or DNP3, and get the data out this port is the only exposed port, and from that you can get the data out. And another key case is sync has got complete upgradation of the protocol, and it's completely based upon the market scenario. It is getting completely updated to new adding new protocol. So by just updating the firmware, customer will get any future protocol that will be supported by sync. In that scenario, customer need not bother about the protocol of the device. It can have a auto upgradation to later upcoming protocol also. In that scenario, customer can have a futuristic device with respect to protocol by choosing this solution. That is one of the key advantage this implementation had offered to them. Now let's see what are the key highlights of Sync 200 series of boards. So first key thing is that it will allow user to migrate their device with the native protocol supported now to standard versions of 61850, DNP3, SNMP, 104, DLMS, etc. Whatever they require in their product, by adding Sync 200 board onto their interface to their device internally, they will get all these protocols. Second point is the integration is very easy, and within 3 to 4 weeks you will be able to migrate with the latest protocol. That is, you are provided with the development board for testing it out externally, then plug the module internally, and your device will be capable of communicating with the latest protocol. Then network redundancy features like PRP, teaming, bonding, etc. are supported. It is available in Sync 261 only. So any device that want to migrate with the PRP, teaming, bonding, etc. network features, they can choose for that. There are multiple time synchronization options like IEEE 1588, or what we call it as a precision time protocol, SNTP, simple network time protocol, etc. are supported in this. Then integration options are available using standard like Modbus to their device, or some proprietary protocols are there. By mutually agreeing to that, we can support that in Sync 200 to interface. Then there are customized configuration engine is there. So we give EC Connect for configuring completely, and we provide a DLL version of the EC Connect so that it can be closely integrated with the vendor tools and can be used for the additional functionality like IP configuring and other stuff. And vendor tool can be used for configuring the existing stuff in their device using the transparent channel functionality. And for the fast data transfer, GPIOs are available, up to 48 GPIOs are available, and that can be linked to Goose or any other messaging system for fast transfer of data. Then another key point is the device is future proof. We are continuously upgrading the protocol and its version. Plus, there is any additional protocol that has come in the market, we used to integrate to the Sync protocol library. So by upgrading just a firmware, the customer or OEM will get the latest protocol with the latest version. That is one of the key advantage. Then we are involved with multiple customers for providing the KEMA certification, that is the protocol certification. Our software stack is certified, and for the end device certification we involve with OEM and get it certified. Also we have experience in hardware 61850-3 certification, so that also we give a support. Then there are API based integration functionality is there. So any user want a detailed interface using API and they want to fetch the data and do the stuff, this can be used, especially in Sync 261 where the capability is too high. It can be used as a the main processor for their own board. So rather than just a protocol upgrade card, Sync 261 can be used as a complete processor, and there can be additional interfaces. In that scenario, API will be suitable for exchanging the data with interface and other scenario. Then we have a development board provided for testing it out with a premium support. If you purchase the development board, you are eligible for a premium support for integration. So these are some of the key highlight of Sync 200 series board. Now we move on to the integration workflow of 200 series. So first the development board need to be purchased, and it has got a RS-232 RS-485 interface, and when you plug the OEM module onto that, you will be getting Ethernet interface. So using the external RS-232 RS-485 interface of your device, connect to the development board, and Ethernet can be directly connected to your computer, and your device can be tested externally completely for migration onto latest protocol. And once you are comfortable with the complete scenario of the testing with the latest protocol, then only take this board and migrate onto the put it onto the vendor device. That is a key advantage. So after testing with the development board using the TTL, I2C, SPI, CAN, all the interfaces, you can integrate with your device directly using these interfaces, and using an interfacing board used in between, you can integrate it internally. So this is very easy integration. Within 3 to 4 weeks, you can get your complete device upgraded to 61850 or other latest protocol by testing it and test it out. The interfacing options in Sync OEM are TTL. It is Modbus and other native protocols can communicate over the TTL. And for the fast message data transfer like Goose, you can use GPIO, directly interface to the Goose. And some of the devices will not have a provision to take TTL internally. In that case, this TTL can be converted into RS-232 RS-485 by using an external level converter, and that can be interfaced internally to your board. There are options to interface like I2C, SPI, CAN. GPIO can be used for the fast Goose and similar messages. RTC can be interfaced using I2C. There are ADC option. There are multiple custom interface options are also there. So depending upon your device, your capability, we are flexible to get it interfaced to your device. That is the key point. Now moving on to most common protocol, and most important thing is 61850, and for Goose GPIO to Goose we use. So 61850 with the complete Goose, then DLMS COSM upgrade for the metering and other application, DNP3 104, then DNP3, if their device is DNP3, it can convert it into 61850, 104. Then DLMS to Modbus and back, DLMS to 61850 for the grid metering scenario, and 101 and 103 to 61850 for some of the other scenarios. Then disturbance record collection and SFTP push, that is another scenario. CSV based event push after getting the data from Modbus, comparing it with the last update, and if there are changes, that event can be generated and stored as a CSV file and pushed over SFTP. Then SNMP is another scenario, 650, and any combination of the above case, server protocol in any combination, multiple protocol can be chosen together, so that is also supported. and any above case with the PRP redundancy for Sync 261. So these are some of the most common used protocol, not limited to this, but we are highlighting most common used protocol. Then time sync option, you have SNTP option. There are server also is supported, so if you want to sync any other devices, that is also possible. Client is available. IEEE 1588, that is precision time protocol, is available. NMEA is available for some of the custom requirement, and protocol specific synchronization like 60870 DNP3 etc. are available, and you can set the priority, like this will have IEEE 1588 will have first priority, and this protocol based synchronization will have second priority, like that you can set it. Now moving on to fast message goose bus, that is how the OEM can be used for transferring goose messages where there is a timing requirement of 4 millisecond or 10 millisecond depending upon the application scenario. So generally in Sync 200 series we use a TTL interface for taking the data from the vendor device, that is over the Modbus or any other protocol, and transferring it over the 61850 as reports on the other side. But Goose, there is a requirement of sending the data in a fast manner, like within 10 millisecond is anyway needed for the application. So TTL interface with 19.2 boards that is normally supported in the vendor device may not be enough for transferring this data. So in order to make that support, what Sync 200 series is having is general purpose IO, GPIO. It is a 3.3 volt level, and it can be converted to any other levels based upon the internal converters that can be used, hardware converters that can be used, and there are up to 48 GPIOs. So these can be linked to your direct IO board. This GPIO can be exposed to direct IO boards, and this can be directly associated with a goose message. So it is direct IO to the goose. So it is pretty fast. It is similar to handling your IOs in an IED using fast scan and other methods. So it does not involve any other communication for fetching the data. So this goose message can be sent out in a faster manner. So this is the advantage of fast message goose bus with respect to the OEM module, and this will enable the device to have fast goose messages by having IO card directly connected to the Sync 200 GP general purpose IOs and sending the goose out. Moving on with the other key feature, it also support 261 also support parallel redundancy protocol for the network redundancy. So that packets are sent out in parallel over two networks. So this is the latest requirement that has come up. It also support link aggregation, teaming or bonding into Sync 261. So two ports of Sync 261 can be clubbed together and used, so that there are redundancy requirements are the met with that. So that is some of the scenario that is needed. Then SOE, sequence of event fault files in COMTRADE format can be transmitted. So there is a mechanism defined for transferring that. So that is also available. And other security support features like NERC 62351 SSL based VPN with multiple encryption are also supported. So depending upon the customer requirement, we provide all these features enabled in Sync 200, means their device will have all these features. What are the difference of different OEM module? Sync 221, 241 and 261. So 221 is the base module with the lowest form factor, and it is having 200 megahertz processor, 32 MB RAM, 256 MB flash, one copper Ethernet port only, no other flexibility. Then 2 TTL interface, up to 16 GPIO, minimal in power consumption, and single Ethernet port, isolated Ethernet port. Dimension and form factor is very minimal. We involved with multiple vendors in getting the KEMA certification for 61850 on 221. 241, going back to 241, it is same platform we are used for 241, but it has got a flexibility of one copper, one ST fiber, one LC fiber, either of the option as an add-on, and it has got up to 48 GPIOs. Dimension is bit high. So this is a pluggable option in which you can choose a copper Ethernet port, ST Ethernet port or LC Ethernet port. Multiple options are there, but same platform. 261, it is a very high-end platform. You can see 600 megahertz here, and RAM also very high-end RAM. So this can even be used for a development, that is a fresh device development board, not entirely as a add-on or a protocol add-on module. Instead of that, it can be used for a device development platform in which your processor will be 261, your basic interfaces of GPIO will be 261, and you can add multiple boards onto that to make this completely your device. That is one of the advantage of 261. So it is very high end processor. RAM is also very high end. 2 Ethernet ports are there. Fiber optic, 2 fiber optic options will be there. So 2 copper Ethernet or fiber optic Ethernet option will be available in the upcoming version. PRP redundancy is supported. PTP based synchronization is supported. Up to 4 serial ports, up to 48 GPIO. Power consumption is bit high, but all other things are remaining the same. So this is a keyboard for your own device development platform. These are the basic differences of Sync 200 modules. Now, having covered the basics on the OEM module, the solution offered for the customer, what are the advantages? So, customer had got near 5,000 installation, and this has made the customer enabled with the latest protocol. Within a month's time, migration to the latest protocol, and there we found that customer gets new requirement from the market, they put to us, and by just updating the firmware, they are enabled with that. For example, SNMP has come up after that. So we, by that time we support SNMP, we have provided that. PRP has come, so we have an option for 261. Then so similar SOE has come up after that. So similar requirement keep coming, but we were able to meet all these with the upgrade. Just licensing is needed for the protocol. That is another scenario. So they can have parallel multiple protocol by just licensing. Then, as I have mentioned, it is futuristic concerning the protocol. So Sync gets updated on all its protocol libraries continuously. So depending upon the market requirement, the OEM or vendor, device vendor need not bother about the protocol at all, and we will provide them the update. So that is completely futuristic on the protocol scenario. So that is one of the key advantage. And fast migration without touching any existing configuration mechanism, all that is preserved with a transparent channel or a pass-through channel mechanism. That is one of the key advantage. So this provides enormous benefit for the customer, not only on the transformer monitoring front, but all other customer. This provides a key benefit. And solution moving, we have already supported this solution to other platforms as well. So this is the one which we have highlighted in this case study. Other platform is protection relays, meters and alarm annunciator, 61850 adapter, then PLC, RTU and controllers, then FPI capacitor banks or RMU, breakers, switch gears we have provided. Another key case is big power supplies. Many power supply has got not used the capabilities of 61850 or 104, so they want this to be integrated. We have few case studies on that as well. Big power supplies using this. Then network routers and switches with SNMP and 61850 support, and any custom applications that can be supported completely with the Sync 200 series board solution. So it is a complete package. It is futuristic. It will enable the customer to have every time updated with the latest protocol. That is the key advantage we are focused. That's it on this session. Do write to us if you have any queries. We'll come with another session on another case study. Thank you.